Hey everyone, sorry that I couldn't be here today. My entire family has come down with something not great. Today what we are going to be doing is we are going to continue solving rational equations, but we are going to focus on rate problems. So let's read problem 9. Paddling with the current in a river, Jake traveled 16 miles. Even though he paddled upstream for an hour longer than the amount of time he paddled downstream, Jake could only travel 6 miles against the current. In still water, Jake paddles at a rate of 5 miles per hour. What is the speed of the current in the river? So let's think about what we know here. So we know distance, right? We know that Jake traveled 16 miles with the current. I'm going to say with the current, I'm going to put a direction to the right. Even though he paddled upstream for an hour longer than the amount of time he paddled downstream, Jake could only travel 6 miles against the current. So 6 miles against the current. And we know that the current, or not, sorry, we don't know the current, that's what we're looking for, but we know that in still water he could paddle at, so we know one rate, 5 miles per hour. And then the other thing that we know, it's harder to kind of pick out because it was hidden there, but this sentence right here means a lot. Even though he paddled upstream for an hour longer than the amount of time he paddled downstream, that's important because that ends up being our entire equation. I know that the time that he paddled upstream is equal to the time that he paddled downstream plus 1. So paddling against the current is upstream. Upstream is against the current, and downstream is with the current. So that's what those words mean. So we can actually come up with an equation from that information. The fact that I know time, I know the time upstream is the time downstream plus 1 because the amount of time spent upstream was 1 hour longer than downstream. So now I need to figure out how I get the information I know the distances and what I don't know, the rate of the current or the speed, into an equation. Well, in Math 1, you guys learned an equation, distance equals rate times time. Maybe you learned it, maybe you didn't learn it, but it is a common sense equation, right? Think about if I'm traveling 50 miles per hour for 2 hours, how far did I go? We would just say, okay, well, 50 miles an hour for 2 hours, I went 100 miles, right? Distance equals rate times time. So that is important because I know distance and I sort of know time, so I can come up with an equation here. To make this easier, since our equation is set up with respect to time, right, the time against the current, the time with the current, I'm going to take this equation here and I'm going to just solve it for time. So let's start with the time against the current. I'll go sub u for upstream. So the distance that we traveled upstream, so against the current, was 6 miles. And the rate would be 5 minus x. We're going to let x be the rate of the current. Why am I taking X away? Because if we're traveling against the current will be slowing our pace down. So if we could travel 5 miles an hour in still water, we would travel slower against the current. So that current is taking away from our speed. I'm going to clean this up a little bit. And now let's come up with an equation for the time traveling with the current. So our time traveling downstream or with the current, well, we traveled 16 miles downstream, and we would be traveling 5 plus x, because if I could travel 5 miles an hour in still water and now I'm traveling with the current, that's going to make my pace be faster. So I'm going to add the speed of the current to the speed at which I'm traveling. So what do I know? I know that the time spent upstream or against the current, I can represent by 6 over 5 minus x. Time spent downstream or with the current is 16 over 5 plus x, and then I have to add 1 to that because, again, it is 1 hour longer upstream than downstream. And now I can solve. This is a rational equation. So first thing I'm going to do is I'm going to rewrite the denominator in standard form, and then I'm going to factor the -1 out because you don't want to have negative leading coefficient. So now I can drag that -1 up to the numerator, and that just makes this rational equation a little bit cleaner. I'm even going to rewrite 5 plus x in standard form. So now it's a little bit easier to find a common denominator. So I'm going to get all of these over the same denominator. X minus 5x plus 5. So I'm going to multiply this one by x plus 5. Oops, wanted to change my color there. There we go. And this one by x minus 5. And then this by both x plus 5, x minus 5. So now both of these are the entire equation is over the same denominator, so now we can drop the denominator. Again, that's because of how adding and subtracting fractions work. And now I can solve. So I get distribute, move everything. I'm going to move everything over to the right. And now let's see if this factors. And it does. X plus 25, x minus 3. So we get two possible answers. X equals -25 and +3. Since our x represents a rate, we're not going to have a negative rate. So x equals -25, we're not going to use, we're just going to use x equals 3. And there's our solution. The current was 3 miles per hour. All right, let's take a look at number 10. So 3 people are planting tomatoes in a community garden. Mike takes 50 minutes to plant the garden alone, Jake takes X minutes and Jeff takes X plus 15 minutes. If the three of them take 20 minutes to finish the garden, how long would it have taken Jeff alone? Sorry. So again, I have a rate problem because we're talking about the rate in which it takes to plant a garden. Where the last example was very obvious, it was a rate problem because we were talking about the speed of the current and we were given the speed paddling. So this example is a little bit harder to determine, but again, we're talking about the rate at which we're doing something. This time, though, we're not talking about distance and speed. This time we're talking about the amount of time it takes to, in this case, plant a garden. So for problems like these, I think it's a lot easier to organize your information in a table. So 3 people are planting tomatoes. We have Mike, Jenny, and Jeff. I know that it takes Mike 50 minutes to plant a garden alone, which means the rate at which he plants a garden is 1 every 50 minutes. Jenny takes X minutes, so the rate at which Jenny can plant a garden is 1 every X minutes. Jeff takes X plus 15 minutes, so the rate at which Jeff can plant a garden is 1 every X plus 15 minutes. If the 3 of them take 20 minutes to finish the garden together, so I also know if we combine all of them working together, they can get it one garden plot done in 20 minutes. So when you're dealing with a combined rate like this, where you know how quick it is, or maybe you don't know how quick it is for everyone working together, and then you have also their individual rates, we know that the sum of the individual rates will equal the combined rate. So the rate at which, Mike can clear a garden by himself, plus the rate at which Jenny can clear a garden by herself, plus the rate in which Jeff clears a garden by himself, gives us the combined rate. So Mike's rate is 1 over 50. Jenny's is 1 over X. And Jeff's is 1 over X plus 15. And their combined rate is 1 over 20. And again, now we have a rational equation, so now we can solve this equation for X. So I'm going to get everything over a common denominator again. So I'm going to multiply this by 2x and x plus 15. I'm going to multiply this by 100. Already have the x, so x plus 15. And then this needs to be multiplied by 100. And x already has the x plus 15. And then this needs to be multiplied by 5, x, and x plus 15. So now everything is over. I'm just going to rewrite this a lot cleaner. 100x times x plus 15. So this is 2x times x plus 15 over 100x times x plus 15. Plus 100 times x plus 15 over 100x times x plus 15 plus, what happened here? right, sorry about that. Move that back. So now we have 100x over 100x times x plus 15 equals, here we have 5x times x plus 15 over again 100x times x plus 15. So now that everything is over 100x times x plus 15, we can drop that denominator. So I get, that's 2x squared plus 30x plus 100x plus 1500 plus 100x equals 5x squared plus 75x. I'm going to combine my like terms on the left side here. So I get 2x squared plus 230x plus 1500 equals 5x squared plus 75x. So now I'm going to move everything over to the right. Oh, what happened here? Why is this not letting? There it goes. So I subtract the 2x squared. That gives me 3x squared. 75 take away 230 gives me negative 155x minus 1500. And you can try and factor this. 1500 is a lot of factors to have to go through. So I personally would probably just use quadratic formula. So we get x equals opposite b plus or minus square root of b squared minus 4 times a times c all over 2a. So we type that in, and I don't have my calculator pulled up here. So I'm doing the work in the background. So that ends up being the square root of a big number, which comes out to be 205. So let's see, 155 plus 205 divided by 6. We get one answer is 60. And then 155 take away 205. This is going to give me a negative number, which again would not work because X stands for the rate in which Jenny plants a plot, which is minutes. Actually, it's time in minutes, so we wouldn't have a negative time in minutes. So that ended up coming out to be negative 25 over 3, I believe. Yeah. So that would not work because we can't have negative minutes. So we end up getting Jenny pull that back up. Jenny would take 60 minutes working alone, but the problem didn't ask for Jenny, it asked for Jeff. So Jeff would then be x plus 15, so 75 minutes. All right. Once you are done with this, go ahead and let the substitute know that you've watched the video, you've filled in the notes, and there's an in-class practice worksheet that looks like this. Come on, there it goes. That looks like this. titled Section 4.5 in Class Practice. There's 4 problems on here, and the answers to all 4 problems are on the back bottom. So you know if you're getting them right versus wrong. So do these 4 problems. If you're struggling with any one of them, feel free to work with each other. As well as I have the worked out solutions on Classroom as well. So you can pull up the worked out solutions to help you through any example that you're struggling through. But try it on your own first. Check your answers when you're done. After you finish this assignment, the rest of the period is for you to work on homework. And I will hopefully be back tomorrow. All right, have a good day.